In this question, we're given a triangle ABC, and we're also given the side lengths of this triangle. We have the line BD, which is an angle bisector at the angle B, so these two orange angles are equal. And we also have line AP, which is perpendicular to BD, and the point of intersection is M. So we're asked various things about whether points are midpoints of certain lines, and I'm going to start by looking at this point M. So one of the things we're asked is whether M is the midpoint of AP. Now, around M, we can see that there's lots of right angles. In particular, angle AMB is a right angle, and PMB is also a right angle. We can see that in these two triangles, PMB and AMB, we have one pair of equal angles coming from this pair of right angles, another pair of equal angles coming from these two orange angles from the angle bisector, and we also have a shared side length. This length BM is common to both of these triangles. So we have two angles that are the same and a common side length in between. This allows us to conclude from angle side angle that the triangles PMB and AMB are congruent. Once we've established that these two triangles are congruent, we can then use this to figure out which other pairs of lengths are equal. So in particular, PM is equal to AM. So M indeed is the midpoint of AP. Another thing we're asked is whether P is the midpoint of BC. Now, if we can calculate the length BP and PC, we could check whether P is the midpoint. Again, due to this pair of congruent triangles, we have BP is the same as BA. And we're given that BA is 85. So we know that BP is 85, and therefore, since BC is 160, PC is 75. So we can see from this that P is not the midpoint of BC. The two lengths aren't the same. We've also just worked out what the length of PC is, because once we know BP, we can subtract it from BC. The final thing we're asked is whether D is the midpoint of AC. For this, we're going to use a slightly different argument. We're going to argue by contradiction. So let's assume that D is the midpoint of AC. In other words, the length AD is the same as the length DC. Then, because we've already established that M is the midpoint of AP, if D was the midpoint of AC, what we could do is we can scale the entire diagram by a factor of 1/2, centered at the point A. So we can bring back all of these points, scaling them by a factor of 1/2, and P would be taken to M, because M is the midpoint of AP, and C would be taken to D, because D would be the midpoint of AC. But when we're scaling things, the direction that lines travel is preserved. So the line PC is parallel to its image under this transformation. When we scale it back by a factor of 1/2, this line MD should be parallel to the line PC. But in this diagram, it's clearly not parallel. Parallel lines should never meet, whereas here, MD and PC do meet at the point B. So it's impossible for D to be the midpoint of line AC. In the final part of this question, we now introduce the other angle bisector at C and the corresponding perpendicular to it. The perpendicular and the angle bisector intersect at N, and I've continued the perpendicular so that it intersects BC at the point that I've labeled Q. we're asked to find the length mn. Now, we can play a similar game to before, where we say CNA and CNQ are congruent by angle side angle, because there are two right angles here. These two angles are equal from the bisector, and the length CN is common. So we know, as before, that N is the midpoint of AQ, and we can work out the length BQ in a similar way that we worked out the length PC. So CQ is the same as the length CA, which is 103, so we can subtract that from the 160 to get a length of 57. This finally allows us to work out the length QP, which should be 160 minus 75 minus 57, 28. And the final step is to notice that since M is the midpoint of AP and N is the midpoint of AQ, we can take a scale factor centered at A with factor 1/2, which will take the length PQ onto MN. So because the scale factor is 1/2, when we shrink from the point A, this length PQ, which is 28, will now become the length MN, and it will be 14. And this finishes the problem.